let's try again. Yeah, mute your microphones, please. I hear somebody's microphone right now. So this is the CPM ebook for 7th grade. When you go to the CPM ebook for 7th grade, you see everything set up the same. What we're doing today is this is lesson 321. So this is chapter 3. So I skip around a lot. We're actually going to go back to some things in chapter 1 and 2. In chapter 2, there was the addition of integers. Today's subtraction of integers. So I'm going to go over some of these problems that are in the CPM ebook, which you can look at later. And I got all the homework problems I gave you, I got from various lessons in here. They're numbered, so you can get homework help if you need it. Make sure, again, if it's asking for a diagram, you draw a diagram. There's a lot of diagram drawings for here. So the first question I want to look at is just looking at these tiles here. What this shows you is a bunch of positive and negative tiles at the right. So I'm going to go to the E tool. And what they're showing you is just a combination of different tiles. So what you hopefully remember is that when you have a positive tile and a negative tile together, that is called a zero pair. So when you have a positive and negative together, and I talked about this on Monday, they basically cancel each other out. It's like if this was a positive one and you added a negative one, it equals 0. So anytime you have a positive and negative tile together, it is called a zero pair. So they basically cancel each other out. So it's like you could get rid of it. Now, zero pairs are really important today with what we're doing. They matter a lot in subtraction. So what you're going to do to find out the value of all these tiles is that you're going to have to get rid of all the zero pairs in order to see what number this actually represents. So if you want to think of this as a addition problem, this is saying that I have 4 plus 3, 4, 5, 6. So this is saying that I have 4 plus a negative 6. So to find out what 4 plus a negative 6 would be, is the first thing you would do is you would, if they had the problem as 4 plus a negative 6, you would draw 4 positive tiles and then add 6 negative tiles. And then to find out the answer, you would have to get rid of all the zero pairs you can make. So 4 plus a negative 6, if I get rid of this, that's 1 zero pair gone, because these just equal 0, so I could get rid of them. Trying not to get everything here. Hold on. I made 2 zero pairs, 3 zero pairs. Sorry, guys. And 4 zero pairs. So 4 plus a negative 6 equals negative 2. So this is what we did on Monday, is we made 0 pairs and you were able to see what the answer is. So if you have 4 and you add negative 6, your answer would be negative 2. So that's how we did that on Monday. Now, for the lesson, if I go back to the lesson, that's basically what it's saying. What happens if 3 positive tiles would be removed? So if they removed 3 positive tiles, they were asking what would happen to the answer. So if in this problem, if I just removed 3 positive tiles and just got rid of them from the picture, they're asking what the answer would be. So when you see that, you could think, okay, somebody raise your hand or somebody chats and tell me what the answer would be for that. I removed 3 positive tiles, so type in the chat box, I could see it. I saw someone say, I saw 2 people, I see lots of negative 5s, good. So, and how you get negative 5 is you remove the 1 zero pair I can, and then I only have negative 5 left, good. So that's basically how it works for addition. It's not too difficult. Now, just like everything else in math, when you go to a different type, it gets more difficult. So now we have to learn about what happens with if you have a problem like this. Let's see, are they going to let me try some? Hold on, let me go to the homework and I'm going to have to click on ones that I want to try. No, I don't want that yet. I just want the tool. Hold on a second. Let me go back. I'm just going to use this because it has all the tools I need. So over here, I'm going to show you on here, I'm going to show you 7 minus 5. So I'm going to represent 7 minus 5. So the first thing I'm thinking, and you know, everybody knows 7 minus 5 is 2, but I'm going to show you how it looks with using integer tiles. So if I have 7, positive 7, 1, 2, 3, 4, 5, 6, 7. And I'm taking away 5. Now, this is where it changes. If I have a problem 7 minus 5, that means 7 take away 5. 7 take away 5. So this represents, let me show you here, blue. So this represents 7 minus 5. Let's see if it'll make it bigger. It won't make it bigger for me. 7 minus 5, which means this is what you would write or think in your head. 7 take away 5. This is what it means. 7 minus 5 means 7 take away 5. So I don't represent 5 at all in my picture. I just think if I have 7 minus 5, I have 7 positive integer tiles, and I'm taking away 5 of them. So I'm taking away these 5. And then what I'm left with is 2. So that you see 7 minus 5 is 2. So that's how you do it. Now that's an easy problem. Now they get more challenging. So if you have a positive number minus a positive number, it's really easy. If you have a negative number minus a negative number, it's really easy. So let me show you a negative minus a negative, because those are easy too. So say I have not making my text bigger. So say I have, I'll do something easy first. 8, I'll say negative 8 minus negative 7. So I have negative 8 minus negative 7. So write that down on your paper. Negative 8 minus negative 7, which is still a relatively easy problem, and you're going to see why. Now, the only difficult part is understanding what negative 8 minus negative 7 means. So how you would say that is you would say negative 8, oops, negative 8 take away negative 7. So that's how you say it. Negative 8 take away negative 7. So what does that look like? If you have negative 8 and you take away negative 7, you might think, oh, I'm subtracting, so my number is going to get lower. But no, you're taking away negative 7 integer tiles. So what this looks like is this. The next one I try, I'll have you guys help me out a little bit. So if I have negative 8, so 1, 2, 3, 4, 5, 6, 7, 8. And if I'm taking away negative 7, I'm taking away those. They're gone. I'm going to put them down here so I don't have to keep on dragging them out. So I took away negative 7. I only have negative 1. So the answer to negative 8 take away negative 7 equals negative 1. And you might think that's weird. That doesn't make sense. I'll show you an easy way to check your work. And some of you might know this already. So how can you check that negative 8 minus negative 7 equals negative 1? It's a new rule, and it's something you might have heard before. It's called, and I'm not looking at text right now, but I will in a little bit. It's called keep, change, change. So write that down. Keep, change, change. And what that means, when you have subtraction, you could check your work. Hold on, someone's trying to come in. Okay, so you could check your work by doing this. Keep, change means I keep the -8 the same. I change the sign to the opposite of subtraction, to addition, and I change the -7 to the opposite of a -7, which is +7. So if you want to check your work that your diagram is correct, do keep, change. Make it -8 plus 7, and then you'll clearly see it's -1. Now, I always get questions like, well, can't we just change it to addition right away and show the addition diagram? No, you have to show me a subtraction diagram because you need to understand how subtraction differs than addition in the diagrams. So you still have to show a diagram that represents -8, take away -7, and show that equals -1. But you can show, to make sure you're right, the keep, change method on the side to show for yourself at least that it does equal -1. It makes sense. So it's, if you do keep, change, it's sort of like what we do for fractions. You could check division by changing it to multiplication. Well, you could check subtraction by changing it to addition, as long as you do it in that way. Text me a question if you have a question. Anybody have a question? Hold on, guys. Okay, I thought two negatives equal positive. Okay, Tommy, when we do multiplication of integers, that's when that rule comes in. When we do multiplication and division on Tuesday, you'll see that yes, two negatives equal positive, and I teach you that on Monday. But subtraction's different. So for subtraction, you use keep, change to check your work, but you still have to show the same diagrams. Okay, let me continue because I want to give you more difficult problems. So this wasn't too hard because you had -7 integer tiles to take away. But that does get more difficult. So I'm going to show you more difficult ones. Daniel, if you missed the explanation, it's okay. It's all going to be posted later. And again, the meeting's going to be on Tuesday from now on. So I'm having meetings on Tuesday and Friday because I wanted to give you more time to do the work I'm assigning today. So it'll be Tuesday and Friday from now on for the rest of the time. Good questions though. So let me continue with a more difficult one. So I'm going to keep that keep, change rule on the side, but I'm going to erase these problems. I'll keep the text box open. It might save me some time. So now let me give you a new problem. Now this new problem I'm going to make more difficult, and I think you'll understand why it's more difficult when we start it. So let me see which one I had written down. Let's do 3 minus a -4. So write this one down in your paper. 3 minus a -4. Now, yes, I could, let me make that negative. I could do keep, change, and quickly see the answer, but I'm not doing that yet. I'm going to show you how to set up the diagram. I'll do keep, change to check my work because this is kind of a weird one. Because again, what this is saying is that you are, let me move this back up. You are doing 3 and you're taking away -4. We're going to find out what it equals. And yes, you probably know what the answer is going to be already, but we're going to do the work first. So I'm going to show you how this diagram looks because like usual, your diagrams are more important than your answer. You could put that in a calculator and get your answer. The diagrams are more important. So let me show you how this looks as a diagram. So the first thing I do is I represent the 3. So I put 3 positive tiles out here. Now it says I have to take away -4. I don't have any negative tiles. What do you think I'm going to do to be able to have negative tiles? Type it in chat. What do you think I'm going to do? Any guesses on what I'm going to do? Because I need negative tiles to take away, but I don't have any yet. Type in chat if you have an idea of what you think I'm going to do. I have to create, think about this way. I can't take away the positives because I have to take away -4. Now think about 0 pairs. I can do 0 pairs. How many 0 pairs will I have to add to this picture to be able to take away -4? Oh, I see three 0 pairs. I see four. I see more 4s. I have to make 4 0 pairs. Now, watch what I do here. Remember, I'm adding 0 pairs to my picture. So in your pictures, in your notes, do this also. Notice, did I change the value of this number? No. This still equals +3 because a 0 pair equals 0. So I didn't change the value of the number. You could add as many 0 pairs as you want. It will not change the value of your number. So I added 1 0 pair, 2 0 pairs, 3 0 pairs, and finally the 4th one. And we'll ignore these guys down here. So notice I added 4 0 pairs, but my number is still worth 3 because these don't have any value. They just equal 0. So now I can finish my problem. It says 3 take away -4. So I could take away -4 tiles, and then I have my answer. Voila. Now, how can I check my answer? Use keep, change, change. So I'm going to replace this problem with the keep, change, change. So I have 3, and instead of minus, I'm going to do plus, change that to plus, and then instead of -4, do +4, and you can see it equals 7. Pretty cool. Make sure you write that down. And again, I'll have the video up so you could review it, but that is a little bit more complicated. But again, that's why you learn about 0 pairs. They're very important in these math problems. Questions before I go on to more? Yes, I did make 4 0 pairs because it's take away -4. So if you don't have enough, if you have no negative signs out there at all, you have to add 0 pairs to get the negative signs to take away. I'll show you another one that's similar, but I'm not going to have to add all the 0 pairs. Let me show you what I mean. So let me try this one. So I'm going to keep these on the side for later. I'm going to change some of my words. Keep those for later. Oh, I see messages. Hold on. Let me look at the chat. To make 0 pairs, you add both the positive and negative tiles until you get the correct answer. Yeah. Okay. So let me change this to, let me do -4 minus, let me do -5. So we'll see how this looks. So this one, I'm just going to change the words. This is -4 take away -5. So that's our problem. Ignore this. Remember, we could check it after with keep, change, change. So -4 take away -5. So the first thing I'm going to do is take out what I'm going to represent my number here, which is -4. So that's what I have. Remember, for subtraction, you don't represent each number like we did with addition, which was much easier. We just represent the first number. Now we have to take away -5. So what do I have to add to my picture to be able to take away -5? But not change the value of the picture. I want it to still be -4, but I want to be able to take away -5. So I see 0 pairs. Now I don't have to add 5 0 pairs because I already have some negative signs out here. So how many 0 pairs do I have to add to my picture? Now I have -4 on there already, and I have to take away -5. I see 4s, 5s. Oh, and then all of a sudden, just type it once, Daniel. I'm going to mute you. I can do that. Just type it once so everybody has a chance to respond. Yes, only one. Let me show you why. Let me show you why. So If I have -4 and I want to take away -5, well, at this point, I could only take away -4. So what I want to do is make one set of 0 pairs. And use these tools. These tools are in the lesson. These are in the e-tools. It's under number lines. You see it says backgrounds, number lines, general tools. Use these tools. They definitely help you out. So I made 1 0 pair. Now, the value of my picture is still worth -4. I didn't change the value because this is worth 0. Now I can answer my question. If I have -4 and I take away -5, what do I have? Well, if I take away -5, oops, hold on. I have +1. What? That's crazy. Why does that make sense? It does make sense. And watch why it makes sense. When I do my keep, change, change, I could check my work. I keep my -4 the same. I change my sign to plus, and then I change the -5 to a +5. So -4 plus 5 equals +1. So that's the way you could check your work on that. It makes more sense why a negative, if you have -4 minus -5, when you check your work, it'll make sense why the diagram makes sense. Could you think about how the 5 is in parentheses and how it's the opposite? No, because the parentheses, I'm only using the parentheses to keep, I'm only using parentheses there so you could see that the negative sign belongs to the 5. That's just a math tool, because look at, if I just didn't put the parentheses here, it would look really confusing. Look how confusing that looks without parentheses. Parentheses are only a grouping symbol, because looking at this is confusing. That's why in math books, you'll see that they add parentheses around the number. And I do that too, because it just keeps, so you know that that negative sign belongs to the 5. So that's why I use parentheses. They don't change the value of anything. They just keep the negative sign with the 5. Questions? Can we use the opposite of the opposite negative sign like absolute value? No, be careful with that. Yeah, well, no, actually, Kate, you could do that. The opposite of a -5 is a +5. Yes, you can, if it doesn't confuse you. Just be careful. Use the method that works for you, because the opposite of a -5 would be a +5. So it works, but just be careful with that, because I don't want it to confuse you more. Keep, change, change doesn't work with multiplication and division. Multiplication and division rules are different. It does work with addition, but you would never want to do that with addition, because it makes it a more difficult problem. Like if I have this -4 plus 5, I could use keep, change, change to bring it back to this. Keep it -4, change to a negative sign, change to a -5. I can do that, but why would you do that? It makes a more difficult problem. So I suggest the only time you really need to use keep, change, change is when you have a subtraction problem to check your work. You still have to make a subtraction diagram though. I'm going to do one more of these, and then I'll take a couple more questions. Oh, let me do this one. This is an interesting one. And I want you guys to tell me what to do with this. So write this one down, the last one we're going to do, 0 minus 4, which I know you know what it equals. But remember, the diagram's more important than knowing what it equals. So I have 0, take away 4. Who has an idea? How do you think I'm going to show this? No, the negative's not always in front. You could have a positive number first. So like I had 7 minus 5 earlier. It doesn't always have to be that. So how do you think I'm going to show 0 minus 4? Tommy thinks I'm going to make 4 0 pairs. Any other guesses before I show you? Remember, you have to represent the 0 first. I have to do 0 and then take away 4. I can't do 4 positives because if I put 4 positives up here, then my value is 4. I got to represent 0 first. So how can I represent 0 and still make it worth a 0? I can make 4 0 pairs. I can do this. So a lot of these answers are right. You can start with this because that equals 0. So you can make 1 0 pair. So technically I already represented 0. This equals 0. So a positive and a negative, that's a 0 pair. So let's make this equal 0. Could I have added more 0 pairs? Can I add 2 of these on here and still have it equal 0? Yeah, that equals 0 too. So at some point you just have to make 0. So let's just have 1 0 pair here. And it doesn't matter if you start with 1 0 pair or 2 or 3 or 20. It doesn't really matter because in the end you'll end up with the right answer if you do the right work. So we'll just start with 1 0 pair. So that equals 0. And I have to take away 4. At this point, I can't take away 4. What do I have to add to this picture here to be able to take away 4 positive integer tiles? How many more 0 pairs do I have to add to this picture? 3 0 pairs, 3. I see 4, I see 3, 4 more, 3, 3, 3. Oh, people are changing their mind, 3. Yes, it's 3. Now watch why. Now, if you added 4, it's okay. You'll just take away more. I'll show you that at the end. But let me show you. I'm going to add 3 more 0 pairs. 1, 2 0 pairs, and finally 3. So I added 3 more. Now, if I just add 3 more, then all I have to do is take away 4 positive, because it's take away 4. So if I take away these 4, I have my answer of -4. Now, I just want to show you something really fast. That would be the answer. But what if I did, a couple of you said to add 4 0 pairs. Okay, say I did put 4 0 pairs, more 0 pairs there. So I had a total of 5 0 pairs. Notice you can still do this and get the right answer. So if I added an extra pair of 0 pairs, it's okay. Because if I take away 4, I'll take away these 4. And then I'd have this left. And hopefully if you see this, you see, oh, I got to take away this too because I have an extra set of 0 pairs. And then you still get -4. So even if you add too many 0 pairs, it's okay because remember, to get your final answer, you got to get rid of all possible 0 pairs to get your final answer. So even if you make a mistake and add an extra set of 0 pairs, it just equals 0. So just take it away at the end. So adding more to this problem will just create extra 0 pairs. Yes, if you add extra 0 pairs, it just creates more things to take away, but it won't change your answer. Now, you have to make sure you only add 0 pairs. If you just add random tiles, you're going to get the wrong answer. So let me go back to this. If I just have this, I take away this, I have -4, which you all probably knew already. And if, again, you check your work with keep, change, change, I have 0, -4, so I'm going to change it to plus, oops, and then change it to a -4, and that equals -4. So checking your work with keep, change, change will help you see that 0 - 4 is the same as 0 plus a -4, which equals -4. Any other questions? Yeah, and like Tommy said, if you add more 0 pairs, you're just creating more work for yourself. But again, the 0 pairs won't hurt the problem. Can we log on to Zoom on the same account but different devices at the same time? Can we log on to Zoom on the same account? Well, when you're on an account, you're basically, when you're on the Zoom account, you're creating your own private chat room. So whatever private chat room code you are on, you could share with more than one device like I did with you guys. Because my private chat room code hasn't changed. It's been the same for every meeting we're gonna have. It's always gonna be the same one, but I'll always resend it in advance. What happens if you can't represent a number? Yeah, glad you could try to do it and see what happens. What happens if you can't represent a number? I'm confused. What do you mean by that? I'm not sure what you mean by that. Okay, give me an example. I could try. You won't have any big numbers for your homework. All your homework problems and all the problems you're going to get are going to be relatively smaller numbers, because so you don't have to show a ton of work. It's just going to show me that you understand. So, Kay, give me an example of a number that you're thinking you wouldn't be able to represent. Type in an example, Kay. Okay, you have an idea? Because I'm not sure what number you wouldn't be able to represent. -6 minus 4. Well, you can. Now I'll show you. This is the last problem I'll do. I'm going to do this one really fast. So -6 minus 4. So I'm going to change that. I'm going to move these away. So that means -6 take away 4. So someone help me out. What's the first thing I do on my picture to represent -6 minus 4? So what's the first thing I do? Put 6 negative signs. Good, I see it. So put 6 negative signs out first. So let me do that. So I have -6. How do I take away 4? So I put the 6 negatives, but now how do I take away 4? Yes, you have to create 0 pairs. Not 4, you can't, now be careful here. You can't just add positive signs, because remember, when you do this, you have to make sure that this stays worth -6. You can't make this worth anything else. So the only way you're allowed to add to this picture is by making 0 pairs. You can't just add random tiles. It has to be 0 pairs. So if I want to take away +4, how many 0 pairs am I going to make? I see a couple. 4. Yeah, Tommy, you can't, it's a +4 because you're taking, that's why I say this is important. I always say take away instead of minus. So you're taking away 4. So I'm going to make 4 0 pairs. So again, this is still worth -6. I didn't change the value. Remember, when you're subtracting, you can only add 0 pairs. You can't just add any old number you want. So I made, let me get rid of all this. So I made 4 0 pairs. So now what do I do to get my answer? What do I have to do to this picture to get my answer? Take away 4. 4 positive or 4 negative tiles? Take away 4 positive. Yes, positive. So if I take away these 4, I then have my answer, which is -10. My answer is now -10. So to check your work, I'll show you here. So to check your work, -6 minus 4 equals -10. And I'll check it with keep, change, change. And if I do keep, change, change, you could see that I have -6 plus, oops, -4 equals -10. So if I have -6 and I add a -4, it's -10. So that's why -6 minus 4 also equals -10. Makes sense. I like hearing that. Good. So I took away the 0 pairs. Not all the 0 pairs. I just took away what I needed to take away, which was the +4. I only had to take away the 4 positive tiles. So you're going to try this problem, okay? You're going to try these problems tonight. Your homework, let me show you your homework now so you can see it. Hold on. Oh, that was the problem. If you guys think you know the answer to that, I just thought that was a funny little joke because it was just showing how if I did the algebra problem, you guys would be bored. See how sad he looks? But when you make it flowers, he's happy. But if you want to try that problem and show me work and submit it to me on Google Classroom or through an email, you could try it. I'll give you a couple points if you get it right. But it was sort of a joke, but if you still want to try it for extra credit, I'll give you extra points for it. Subtracting. This is the homework you're going to get. That this one is going to be due Tuesday. So please complete the following problems on a separate sheet of paper. Finish before our meeting on Tuesday. Show all work. Again, you need to submit this work, either submitting this by PDF scanning, taking a picture of it, emailing me, send it however you can. Get this to me. So you'll see these, they're giving you a certain number of tiles to start with. They want you to use this diagram and show how you can get these answers. Now, if you want, you could just create your own diagrams from the start, but they wanted you to use these tiles at first, but do that any way you want. These are more diagrams you have to do here. 3-38 goes over some review of multiplication, subtraction, and addition of fractions. On this, you're just making this expression. Now, this is a little easier because it's all addition. So you're gonna, this is just have 5 plus 4 plus 2. 2 times -3, I'm gonna tell you right now, if you have 2 times -3, I'm gonna tell you, since that's a little bit trickier, that just equals -6. So basically you have 5 plus 4 plus -6 plus 7 plus -5. So I'll tell you that now. So that helps you out. And you do have homework help on this if you go to this problem. Follow the rules or the directions on that. So do all that work, submit it to me with work, a lot of diagrams on here, or fraction work, and then you'll get full credit for that for your effort. Now, effort means you really tried. I will go over if you have mistakes on it, but effort means you really tried on it. I see questions. Hold on. Virtual candy. I wish I could get virtual candy. I'll give you virtual dojo points though. So we've done one like this. Yes, if you're talking about the homework, can you print stuff out from CPM? I don't know if CPM will let you print. You probably could take a picture of it, or I think on my keyboard I could do Shift Command 4 and I could take a screen capture of different parts of the screen. Where do you find this work? I didn't post this one yet. The subtraction of integers, I'm going to post on Google Classroom later today. I'm going to post that. I have to make this video and put this video on YouTube. So I got to put this video on YouTube. I'm going to post a couple extra helpful videos that on this concept. And then I will also post the homework all at once. The homework is a PDF file. So when you get the homework, it will be a PDF file. So don't worry about that. Maddie's trying to join. Okay, I don't see her in the waiting room. I'm not sure. Yeah, the class is almost over. Are you going to put everything on Google Classroom? Yes. Later in the afternoon, because I have another meeting in about a half hour. So later this afternoon, probably after 4 o'clock, I will post all of this on Google Classroom for you guys. The YouTube video will be in Google Classroom. It's also on my YouTube channel. Yep, I have a YouTube channel. And the YouTube channel is just under Doreen Hofflin. But anytime you click on any YouTube video in Google Classroom, it'll bring you to my YouTube channel also. So you could go through that way too. Yeah, put everything on Google Classroom. Oh, we have a visitor. Hi, Sammy. You gonna say hi? They only seen pictures of you. Now they get to see you in person. Hi. Hello. Yeah, she's